Good morning, everybody. Welcome to today's Kundinger Presents featuring the Parker Pneumatic Division in their new innovative PCH Network Portal. I'm Paul Kundinger, your host, and in a few minutes we'll be joined by Ashwin Rain, Product Manager from the Parker Pneumatic Division, who will present on the PCH Network Portal product. I'm going to launch a few polls here while we go through some other information before we get started. So you should see a poll pop up on your screen and answer that when you get a chance. We've placed everybody on mute. If you have a question during the presentation, please use the chat feature in the control panel. We will be monitoring the chat and we'll answer those questions during the presentation. And then we've also allotted time at the end to answer any of the questions that may come up. After today's presentation, if you have any further questions or want to further discuss Parker Pneumatics and the PCH Network Portal, we ask that you reach out to your Kundinger contact. If you don't know who that is exactly, you can email us at sales@kundinger.com or call our office at 1-800-242-4811. In the control panel, you'll also see a materials section. Under that section, we've added some PDFs and white papers for you to download that offer more materials regarding today's presentation on the PCH Network Portal. So those can be downloaded at any time, and if you need those at a later date, we can also get those to you as well. I'm going to close that first poll question. So it looks like we've got 71% of the attendees that are familiar with IO-Link, and I'm going to now ask the next one. We are recording today's session, and it will be available on our Kundinger Inc. YouTube channel for future review and to share with your colleagues. Just go to YouTube and search Kundinger Inc., and you'll find our channel. We also have previous presentations that we've given out there on other products, and we'd be more than happy to discuss this one and any others with you and your colleagues at a future date if it requires. I'll give this poll another couple of seconds here, and then we'll close it down. Last chance to answer the poll question. All right, looks like 50-50 split there on preferred configuration method, PLC and web page via Ethernet. With that, the polls are closed, and I'm going to unmute Ashwin and turn it over to Ashwin to carry us through on the PCH Network Portal. Ashwin, you should be unmuted.
Okay, can you hear me now?
I can.
Awesome. Okay, thank you everyone for joining today. It's a real pleasure to get to show you this presentation, show you guys some of this new product. My name is Ashwin Rane. I am a product manager over here at Parker Hannifin's Pneumatic Division. We're headquartered over in Kalamazoo, Michigan. So we're over here on the Eastern Standard Time. So we're really excited to get to show you this. Thank you, Paul, again for hosting us. I have two other folks, very important folks on the call today. I have Courtney Castillo, who is the Pneumatic Territory Manager for your area. So Courtney, she's gonna come in as well. Paul, if you don't mind unmuting her too at a certain point, and discuss an application actually that she worked on. Along with that, somebody who's not on this list is also Greg Davidson. Greg Davidson is a seasoned career controls engineer who is here and is open to answer any questions you guys have. He is a great support, help integrate, just answer all those random questions that come up when you're integrating stuff like this, right? So if you guys have any questions, put them in the chat. Paul, if you wouldn't mind just cutting in if there's a chat that we can address, and we'd be happy to answer it. Now, right now it is, I think in your time zone, it's 9:07 or 9:08. So this presentation, it's going to be right around 35 minutes or so. So we're going to have a little bit of time in there for any questions you guys have. What we're not going to do is cover in-depth IO link. So it looks like a good amount of you are familiar with it. However, if you guys have any questions about IO link, please don't hesitate to reach out. Happy to answer any. Along with that, in the materials tab on your dashboard thing right there, there's a variety of links that you guys can download. So there's we actually have 4 white papers that we published about the PCH portal. Along with that, we have a link to our webpage, a link to our brochure, and then we also have a link to the H series ISO valve. So we're not going to talk a lot about pneumatic valves here today. However, we do have a full product offering of valves from a lot of different flow ranges that are available to attach to the PCH Network Portal. So a lot of material is online about that, and you're more than welcome to ask any questions about that. But okay, we're going to talk about PCH Network Portal. What is the PCH Network Portal? It is essentially a field bus controller for your network, as a comm module that links up to your pneumatic valves. I'm going to talk about the portal, its capabilities, and essentially explain the design approach that we took over the course of this presentation. Flexibility and configurability are the foundation of this platform. So we're going to cover that. We're going to talk a little bit about diagnostics and system architecture, right? A lot of the folks on this call today, controls engineers. So that's generally what concerns a lot of you folks. We're going to have Courtney talk a little bit about an example, and then we're going to talk a little bit about the values that we use to design this. So a little history. This is a new product for us. We launched it a couple months ago, and this is the product of many years of development. So years ago, we scoured the world, conducted a lot of different interviews, asked folks, hey, a lot of the solutions that are in the marketplace, well established, but how can we improve upon them? And that's really what you're going to see today. Now, what exactly did they tell us? I want to share that with you. There are 3 main drivers that they gave us. They said, hey, if you're going to design something new, it has to be flexible, right? So flexible design to minimize our machine costs. We need something that can fit in multiple applications. Folks also told us, hey, we need to be able to start this up a lot faster, intuitive interfaces for shortening that startup time. And then another bucket said, hey, we need diagnostics streamlined for decreasing our downtime, right? I think a lot of you guys have probably seen all these diagnostics that are out there in the marketplace, but it's almost like there's too much, right? And you don't always know what to do with it. So we took an approach where we could do a little bit more with those diagnostics than what other folks have been able to do in the past. Now, we also found that these buckets kind of fit into 3 different profiles, or personas, we like to call them, in your shop floor. So the folks that specify it, the folks responsible for putting all the wires in there, and then the folks that are there to maintain it. And we made sure that we designed a solution that appealed to all those different personas. So here's the network portal. We call it the PCH Network Portal. Again, a lot of work went into this. Available in Ethernet IP, Profinet, EtherCAT, Modbus, and I'm gonna leave this picture here in the center, and I'm gonna point a few things about it as we keep going on. Here's a view from the top. Okay, so on the left here, this probably looks kind of familiar, right? So you have your comm module on your left, and you have all your valves on the right. Okay, again, on the right, that's our H series ISO valves. So it's a valve series. It's universal. You can plug and play, really. You can move those valves wherever you want. We call it universal because we really wanted folks to be able to have one solution to fit all of the different flow regimes on your plant floor. Okay. Now, you may be asking, hey, you know, a lot of the things that I've seen in the past, generally they're like add-ons, you know, they're like, it's like Legos, you kind of put what you need. Now, the biggest feedback that we got from folks was that, hey, you know, that is what we used to use. However, nowadays with more distributed networks, we don't need that much IO. You know, 24 IO points meet the majority of our customers' needs. In fact, most people said, hey, we only need 16 IO at this point. So we said, you know what, let us give you a solution that is flexible in that context. So they still said, hey, you know, we don't need that much IO, but we need a variety of IO. You can't just give us 24 digital inputs NPN. That's not going to fit our solution. So we said, okay, we need to think about that. How are we going to fit that? So we took this approach. We simply designed a lot of, not simply, we designed a lot of circuitry into here to the point where we could ask this question over here on the left of the slide. So I'm going to point out this port here, you know, our port 0, our top left port. And I want to ask you, hey, is that a digital output? Is it a digital input NPN? Is it a digital input PNP? Is it IO-Link A or IO-Link B? The answer to that is it can be all of those things. Now you're saying, okay, Ashwin, that makes no sense. Don't worry, I'm going to explain how we do this. We do this with what we call true port configurability. Okay, so I'm going to continue to explain that as we keep going, but the long and short of it is we've integrated a lot of switchable circuitry into this device to give you that kind of configurability. And some of the other things that we have designed into here, oh, there we go, are things that, you know, some smaller things like large writable labels, you know, large 120-degree viewing angles for LEDs with super bright LEDs so that you can troubleshoot what's going on from a distance. At the bottom left here, you're seeing not only in power, but you're seeing a connector to go out. And I'll talk a little bit more about that as we keep going. Underneath this access cover in the center, you're seeing, or underneath there, you'll find rotary switches, because we got a lot of input saying, hey, we like the classic rotary switch approach. And then you're also going to find a USB type B connector. This is the kind of connector that plugs into your printer. You're going to see some network ports on your bottom right, and then you're going to see, you know, regular M12 ports on the rest of the device, okay? So again, lots of different things that are built into here. I talked a little bit about that truly configurable IO. We've also integrated IO-Link master ports. So a lot of folks familiar with IO-Link, you don't need to have IO-Link to use this, but if you are using IO-Link, hey, it's built in there for you. This housing, IP65 Weld splatter resistant housing, we do this kind of material now on all of our network nodes because we want to survive in a Weld noise immune environment, or sorry, in an environment with a lot of Weld noise. There's electric zoning and with the ISO valves pneumatic zoning. This is safe power capable, up to 32 coils, so you can have 32 ISO valves. And we're going to talk a little bit about an exciting feature, secure and lockable Bluetooth. Okay, so I'm going to show you something that we don't normally show to folks. This is the hood taken off of the portal. And this is how I'm going to explain how this works essentially to you. So there, you guys saw 8 ports on the left and 4 ports on the top right. Here's that same thing. Again, 8 ports bottom left, 4 ports top right. What you're seeing here, it's actually not like one board that fits all of them, right? You're actually seeing 3 boards, right? 1 board for 4 ports. And what we call that at Parker, we call those module positions. So there are 3 module positions in the portal. There's a module 1, there's a module 2, and a module 3. Now, all of those look green, right? I'm going to show you that we have different types of these boards that we can put in each of those modules positions for your application. Okay, so here's a different view from it, looking from the top. Again, module position 1 in the top left, module position 2 on the bottom left, module position 3 on the right side. Okay, now I showed you guys the green version of this. There are 2 different variants of this. There's that B and there's a C. You know, let's say just you know, blueberry and the cherry version. Okay. Now, each of these variants, they're capable of different things. So let's just talk about that A module position to start out with. And again, these can go in any different module position that you want, okay? So that A module variant is capable of a lot of IO-Link class A needs out there. So each of these ports can behave according to what you want. So this is after you get it into your shop floor. You can go into the software and you can say, hey, I want this top left port to serve as an IO-Link Class A master port. Okay, well, hey, let's say suddenly you have two inputs that you need. Now I can just simply go into the software and say, hey, nope, I'm gonna have that behave as two inputs. Is it PNP or NPN? Doesn't matter for our application. They're both built into there. So there's no longer two sets of part numbers that you need for PNP and NPN. You can just, it's a simple click of a dial in the software. And then if you need two outputs, that's in there too. So you have three options for each port. Each port can behave as an IO-Link Class A, or two inputs, or two outputs. Again, those outputs are 250 milliamps at 24 volt DC. Okay. Now the B variant, it can behave for IO-Link Class B scenarios. So each of those ports, similar to that A, it can behave as three different options. However, these ports can behave as an IO-Link Class B master. One input, again, PNP, NPN, doesn't matter for us. It can be either of those, or one output, right? And that Class B, that's where you're getting that power and communication over one cable. Okay. Now we also have a C variant. Now, folks told us when we were designing, hey, you know, the idea of doing configurable outputs really cool, but sometimes we just need some dedicated Aux Power ports on there. So we went ahead and designed that in here. So those top two ports, they are fixed. They behave as 500 milliamp outputs on Aux Power. But the bottom two ports, what you're seeing on the bottom here, they can each behave as an IO-Link Class B, one input or one output. This is kind of like that last module variant I showed you. Okay. So each of these has kind of a nickname to help differentiate them. So you're on your far left, the green one, that we call that our Class A variant. Now, they don't need to behave like IO-Link ports, but if you need them, you have them. Your center one, that's your B variant. Those they can behave as IO-Link Class B. On the right, we call it our high watt. Now, you may say, hey, Ashwin, okay, 500 milliamps, is that really high watt? Well, we're already working on the D variant, where we'll have even higher wattage ports, with the hopes of eventually controlling things that are in the 1 to 2 amp range. Okay, so I'm going to show you again the top. You may be asking a lot of questions as to, hey, where do these variants go again? So let me show this again to you. So on the top left, again, position 1, position 2, position 3, right? When I put the cover on, you can't really see what's inside. You can see what's on the label and all that, but we tried to streamline it so it's not as crowded on the top. But you guys can know on the inside, all of those different positions can have different variants. So I could have an ABC or an ACC or a BCC. You can choose what you want per your application. So if you say, hey, I need 8 Class A IO-Link ports and I need one input, you can do that. You don't need to buy a bunch of different slices for your application. You can just buy one part number and change it accordingly once it's through your door. Okay. Now there is a blanking plate available for our position 3. Let's say you only need 8 ports. We found folks like that as well. So in case you need that. All right. So that is what we call true port configurability. Now, if you have any questions, please go ahead and ask them now. I know that's a lot. It's a very different approach, but we have found that folks really love this level of flexibility. Okay, so if you have any questions, put it in the chat. So now I'm going to talk about power configurability. Okay, now for the power configurability, we took this approach. Hey, we saw that a lot of folks are switching to 7/8 inch connectors for their plant floor. So for the application or the power configurations I'm going to talk about, just remember they can either be a 4-pin or a 5-pin. Every connector that we have at Parker, that 7/8 inch in pneumatic division, can always be ordered as a 4-pin or a 5-pin. There's also ADA connectors available. I'm not going to talk a lot about that since that's generally in Europe, but if you need it, we have that. Along with that, I told you guys, right, there's a power in and a power out connector, right? Well, I'm going to show you a power option that you have where you have two power in connectors, and we can do some cool things with safe power zones that we're going to talk about. So to get started in talking about power, I want to show you the portal loaded up, fully loaded, okay? So here I have a bunch of valves connected, right? Well, I have 32 coils. So these are each valves that are double addressed valves, or double solenoid valves, 0 to 31, okay? Now, the first power option is probably what you're familiar with the most. So you got one pin, it powers all of your coils, 0 to 32, and they're really on one zone. So if you want to switch them all off, you just, you can cut that pin off. This is what's really established in the marketplace. Again, 4-pin, 5-pin, 7/8 inch power connectors. There's also a power budget we like to talk about. So for that power out connector, you are able to actually pass through up to 20 amps of power. So the PCH portal has a max on it. It'll consume at a max of 8 amps of logic power and a max of 12 amps of aux power. And whatever is left over, you guys have at your disposal the rest of the plant floor, that is up to 20 amps. So we really love that this offers you that flexibility in your power architecture, allowing you to simply daisy chain your power in the same way that you daisy chain, your network communication, right? What I'm going to show you is our second power option, okay? This is what we like to call our safe zoning. So on the actual power connector, again, that right power connector in your bottom left that you're seeing in red, you're having two power connectors go in, and on that right connector, we actually have isolated safe grounds that help you establish two safe zones. So your first safe zone is the first 24 addresses. Your second safe zone are your last 8 addresses. This module that you're seeing right in the middle, kind of sandwiched between your first and your second zone, that's our expansion module. So if you need to get to that last 24, 31 addresses, you can pick and place and put it anywhere you need. Now, I get folks asking me, hey, do I need to use all 24 addresses in order to get to that second safe zone? No, you don't need to do that. Pretty much wherever you put that middle expansion component is where your second safe zone begins. So you could say, I want 8 double solenoid valves on my first safe zone, and then I want 8 as well on my last safe zone, and you can achieve that. Okay, so again, this is safe power with isolated safe grounds. So this is all safe power capable, OSSD, test pulsing, all that good stuff. Now you may ask, hey, are you gonna do some of that functional safety stuff one day? We do intend on doing that as an expansion of this product. Okay, now that is electric zoning, right? But we also have pneumatic pressure zoning, and that's built into our pneumatic manifold. We also have pilot pressure zoning, which is a result of what we call our Parker PXM zoning module. This is another product that we offer. So zoning, we've been told this is very important. The market has told us this is very important for your applications. When folks need safety, we want to be able to give you the right power zones and pneumatic zones to achieve those levels of safety. Okay. So I talked about port configurability. I talked about power configurability. Let's talk about configuration. So Paul, you conducted a poll earlier. Thank you for that. Talking about, hey, what are the ways that folks like to configure devices? And this is what we've been told in general. It's a split between folks configuring their devices via PLC and Ethernet. Okay. Now, what we've done, we've added this ability to take a USB Type B connection or wire and plug right into the portal and configure the portal via some software on your laptop. Now, all that software, it's the same thing that you're going to see on the web page. So if you dial in via the IP address, you're going to get a very feature-rich, web page environment, and I'm going to show you that in a moment. But what we've added to this is what you're seeing on the bottom. So you can actually connect to this device via Bluetooth on your laptop or Bluetooth on your phone or a tablet. And that's Android or iPhone. Now we're currently releasing this application, but what can it do? Let me show you what it can do. that app, that Bluetooth app via your phone or tablet, it can do things like changing configuration. So changing what your ports do. You can test fire outputs and valves. You can view inputs in real time. You get a very rich rolling errors, warnings, and events. There's actually 40 errors, warnings, and events that you guys can see, and I'll show you guys that in a moment. You also get live diagnostic and status views. Now, you might be saying, hey, Ashwin, okay, now hold on, put the brakes on. I don't always want people to be able to do this on my plant floor. We agree. So this is all password lockable. Hey, if you don't even want folks to be able to use this, you can do that. Okay, so we made sure secure and lockable is built in to that kind of technology. Now, the web server via Ethernet, they can do everything that app can do and more. So you can do things, again, like you can upload and download configuration. So let's say you have 3 of these or 10 of these on your plant floor. You can configure one device, download the configuration onto your laptop, and load it to all the other ones. You can upload your IODD files. For those of you familiar with IO-Link, you're probably familiar with IODD files. You can do that from this interface. And then we also have the same interface via USB Type B. Now, I'm going to show you what that interface looks like in a moment, but I want to take couple seconds just to talk about diagnostics. Now, diagnostics tend to be kind of a touchier thing. You know, some folks say that, you know, they love it. They're like, the more information, please give me more. But some folks say, hey, you know, too much information. I don't know what to do with, you know, with all of it. So we said, okay, we're going to give you these diagnostics. You can use them how you'd want. But in those feature-rich interfaces, we're going to show you how to interpret some of that. So we're not going to say, error flag 64, go see the manual. We're going to show you, give you some text to tell you what to do with it. Some of these diagnostics are actually built into some of our other platforms already. So things like cycle counters for valves, short circuit detection, overcurrent warnings. You know, if you're on the plant floor and you get a flag at 3 a.m. that, oh, there was some voltage dip, it can be really difficult to figure out what happened. Well, hey, they're time stamped now in your PCH portal. And on top of that, the PCH portal actually has a battery in it. So it'll store that information for you. You're not going to lose it. Okay. Now, parameter diagnostics and process diagnostics, we have different things in them. I kind of told you what's in that process data. In the parameter data, you get things like aux logic, voltage reading, cycle counting, all that good stuff. And we also are making a lot of function blocks, AOIs for folks for integrating these things. There's a lot of diagnostics built into this, 237 total diagnostics that we can communicate. But let me show you what that looks like. So here's a screen capture of me connecting to a device on my laptop. And this is the same thing you would see in the web page. And what you're actually seeing me do is connect to a device via Bluetooth. So I think I was sitting maybe 20 feet away from the actual device. I'm just going to pause it for a moment here. Now, this is the first status screen that you're seeing on the actual device, right? So you're seeing things like aux power, logic power. You're seeing your IP address, serial numbers. You're seeing the status of your valves that are connected to it. You're also seeing what the ports are doing as well. Now, on the top, on those banners, you're seeing status configuration, force mode, log. I'll show you that log. But what I'm going to do here is simulate a power dip. So look at the bottom left here. Okay. Now that aux power just dipped to 19 volts. So it's giving you a red status light. You'd see that on the device. It's telling you, hey, you have low voltage. Now it went back up. Now this can be difficult to diagnose, but if you go to the warnings log, you're actually going to see a time-stamped event of when that happened. So here's the time-stamped event. I'm going to pause it here for a moment of when that happened, what happened, right? So there's that low voltage. And then here's some remarks to help you. We're seeing a lot of turnover and new folks entering the controls, profession. We want to give them tools to help them do their jobs better. So it'll tell you, hey, you lost your auxiliary voltage. Maybe, go power cycle something, eliminate a noise source, replace the device. We've catered all of these remarks to help you do that job a little bit better. All right, and again, this is time-stamped rolling 40 warnings and events. So you get 40 warnings, you get 40 errors, you get 40 events. All right. Now, I'm going to take a moment, talk about system architecture. And Courtney, I'm going to have you come on in a moment and talk about an application. But I just want to talk about the importance of system architecture. So if you guys know about IO Link, you guys probably also know the ease of expanding a network like that, right? So, while we, have 24 ports on here, or sorry, 12 ports on here, you can expand this using IO Link. So we have a line of node technology IO Link devices. Here's just one quick example of where you have one portal that can power, 128 inputs, 96 valves on those IO Link modules, 32 valves on the PCH Network Portal. This can be endlessly expandable when you use this kind of technology. So we really like showing these kind of things. We're happy to make system architectures for your examples if you have something, because it's really important when you're considering devices like this. So Courtney, I'm gonna try to bring you in and take 4 slides here and discuss just an application where you were able to implement the PCH portal.
All right, so again, my name is Courtney Castillo. I'm the Wisconsin Pneumatic Territory Manager. So I live in Green Bay and I travel the state to visit customers and assist with these kind of projects. So this is an application at one of my customers where they were looking at moving away from collective wiring to be more of to upgrade basically the technology on their machine. This is at the end of a rewinder and it's called a turret. So the sensors that they had was these, 2 ultrasonic ones, these 12 proc switches, 2 thermal sensors to help with the motors. They did have 16 solenoids, 8 spares, and 2 dry contacts for their relays. Next slide. So they gave us then a picture of what their controls cabinet looked like, and I kind of made it into this type of a slide so that it's just easier to see. So as you can see, we have the different IO slices. And next slide. So when we looked at this, we realized and came up with the conclusion that over half of this panel can be replaced by PCH Portal. And it was, so when we look at the cost comparison, these cost numbers actually came from our customer. And this labor savings also over here was from our customer as well. So overall, we were able to, reduce the number of part numbers being used. We were also able to reduce the overall size of their cabinet. Because they were hardwiring also, most of that would be IP20. So going with this PCH portal, which is IP65, realistically, they could just get rid of the cabinet because, again, it's IP65, which would be suitable for their environment. And as far as the analog sensors, the only add we had to do was just to have that converter to convert them to IO Link. Overall, the customer did have an estimated 21% in savings, and this is just one small part of the machine. We do estimate that the savings could be or would be even greater, and they agreed as well if we looked at the overall entire machine. So.
All right, thank you, Courtney.
If you're ever interested in having us look at an example, please give us a call. I'd be more than happy, to work with Greg Davidson, as well as you to come up with a cost analysis for your application.
Thank you, Courtney. So we're in our final slides, guys. So thanks again for your attention here. Some final notes on system architecture. So I've shown you a very different approach to this kind of true port configurability, but here's an example of what it could look like. So where you have different types of IO all on the same platform, right? So you're seeing things like digital inputs plugged in, digital outputs, IO Link Class A, IO Link Class B plugged into here as well. You can get one part number, one CAD file, right? So one configuration file that can match and meet all of these needs, and that's really what we're going for. You know, a lot of the current applications that are out there, you know, that Lego approach to doing it, it worked for a good amount of time. However, it led to a lot of complexity. So if you guys are used to speccing those kind of applications, you're probably also used to having to purchase, you know, maybe 10, 12 different components for one manifold. Here, you have one part number for that one for that one PCH portal, right? So let me just quickly sum up our value here. So again, at the very top of this, we talked about flexible design to minimize machine costs. We talked about intuitive interfaces for shortening startup time. We talked about streamlined diagnostics for decreasing downtime, right? And we made sure that we could fill all these different things up with features and benefits of the portal that we really believe are geared towards different personas on your plant floor. Because let's be honest, you know, you guys, you guys are our customers, but you have customers too, right? So we want to make sure you have different features here that you can pass on the benefits to your stakeholders. So again, things like power in and out connectors, built-in programming functions for your controls engineers. Like there's debounce timers, there's counters all in there. You can invert signals in it, all built into the actual portal. Improved local LEDs for troubleshooting for your maintenance folks. It's a simple thing, but it goes a long way where you don't have to get very close to the actual device to figure out what's going on. That Bluetooth web app, you know, you don't need to be right next to the actual product to figure out what's happening to it. You can try to diagnose what's going on simply via Bluetooth or those LEDs. Power in and out connectors help your integrators out there. You know, one single footprint that can match different configurations. So we made sure we built in all these features to give you the most value that we could. So this is my last slide, guys. We're at 9:40. We have a lot of different material that's available on this device, but actually all this material, it's already linked in that dashboard in the material tab. So we have a variety of different white papers that we've written that can help explain essentially how these different benefits might be able to serve you in your application. We have brochures and catalogs, all the 9 yards for that as well, and these links are available to you as well as, you know, on our Parker website. So again, I want to thank you all for your attention. You know, this was a really great opportunity to show you guys what we've been up to here at Parker PDN. Now, if you're new to some of our solutions as well, you know, valves, communication modules, it's not the only thing we do. You know, we have a full range of actuators, we have a full range of FRLs that we are always trying to improve, that we the bulk of, you know, which we generally try to make over here in Michigan or in Ohio. So we're also not too far away from you. So thank you again. Paul, do you have any closing comments or questions that came up that I can answer?
Yeah, we did have one question, Ashwin, that came up in the chat, talking about lead time and availability.
Right, good question. So we are targeting a 10-day lead time on this. This is made, actually, you know, this is a point we try to make very clear to everyone. We make this product in Kalamazoo, Michigan. So the boards, you know, the circuit boards, everything, we source them from a supplier down the street. Our housings, our injection molding done, you know, 20 minutes the opposite direction. So we've tried to localize as much the production of this product here in Western Michigan, and we're really proud of that. So you know, if you guys ever have a scenario where you want to trial it, or you know, you need some, you know, a large quantity, please get in touch with Courtney. Happy to engage in that and try to meet your demands.
All right, thank you for that. I'm going to unmute everybody right now just to see if there's any last minute questions anybody would like to ask. Everybody is unmuted, so ask away. No questions. All right, well, I wanted to thank you, Ashwin and Courtney, for presenting today. We appreciate you taking the time and sharing this new technology from Parker Pneumatic Division with everybody. Also want to thank all the attendees, and a reminder, as we're going through some of these last minute informations, There are the downloads available in the materials section, and then if you still see Ashwin's screen, those are all available at that parker.com/pdn/PCH portal website as well. If you have questions after this, be sure to reach out to your Kundinger contact. And as I said before, if you're not sure who that is, you can email us at sales@kundinger.com or pick up the phone and call us at 1-800-242-4811. Follow us on LinkedIn to stay up to date on future product information and future Kundinger Presents presentations. Again, thank you everybody for participating today, and we look forward to seeing you on a future Kundinger Presents.